Question 7. A lab technician is a test for consistency by making multiple measurements of the cholesterol level in one blood sample. Target precision is a standard deviation of 1.0 milligram deciliter or less. So if 10 measurements, so n equal 10, that's given, 10 measurements are taken, and the standard deviation is 1.6 milligram per deciliter. Standard deviation, so because you measure 10 measurements, so this is a sample, standard deviation S equal 1.6 milligram per deciliter, S equal 1.6. Is there enough evidence to support the claim? And what's the claim? That her standard deviation, which is standard deviation, which is sigma, is greater than the target, greater than 1.0. The target precision is a standard deviation of 1.0 mg. So question asks you, is her standard deviation sigma is greater than the target? The target is here say the target precision is a standard deviation of 1.0, so it's greater than 1.0. This is the claim. Since greater than, so there's no equal sign. If so, is for H0 alternate hypothesis have an equal sign. Equal 1.0 is for the null hypothesis, and then at the alpha significant level is 0.05, alpha equals 0.05. Since this one is we need to use the degree of freedom, because this is for the standard deviation. We will use chi-square distribution. For chi-square distribution, we need to find out the chi-square table, use the degree of freedom. Degree of freedom, because n equal 10, so n minus 1, 10 minus 1, degree of freedom is 9. And since the original claim is greater than this pointer, point to the right, so this is the right tail test. So, and use, because for variance standard deviation, you will use chi-square. Chi-square for this one. Chi-square test for variance and the standard deviation, use this chi-square. Chi-square test. Use chi-square test. So first of all, we draw this chi-square curve. Chi-square curve is always positive, because square is always positive. It's to the right, to the 0 is always positive. And then this skew to the right. Now we here is point to the right, so it's a right tail test. So we draw this on the right tail. Alpha equal 0.05, total alpha, total to the right tail. So this tail is 0.05. And then we look at the chi-square table. The chi-square table is the chi-square distribution. This chi-square distribution. And this table, we looking for alpha is this area to the right, and we can figure out the chi-square corresponding chi-square value. Now this question, alpha is 0.05, and we need to figure out this chi-square right. So 0.05, it's alpha equals 0.05. you look at the top. Top is alpha 0.05 here, 0.05 here, and degree of freedom is 9. So look at the 9. Degree of freedom is 9. The intersection 9 and the alpha is 0.05 is 16.919. So that's this chi-square right is 16.919. This is a critical value. To the right, if a test value fall to the right, that's in the critical region, we will reject H0. So then we figure out test value. Test value is a chi-square, is the ratio between variance of the sample and the variance of the population, population, the ratio, S squared over sigma squared and times by degree of freedom, n minus 1. So n is 10, 10 minus 1, and S is 1.6. So 1.6 squared, and the population standard deviation is 1, so it's 1.0 squared. And then figure out this is 23.04. And look at the 23.04. The test value 23.04 is falls into rejection region, critical region. Rejection region also say critical region. Since 23.4 is greater than, is to the right of 16.919. So this test value 23.04 is to the right of critical value 16.919. So this test value is falling in falling into the rejection region. So reject H conclusion, reject H0, support H1, reject H0. So therefore, original claim is this. So therefore, there is sufficient evidence to support the claim that her standard deviation is greater than the target. Then question 8. Use the chi-square. Use chi-square table and find the p-value interval for the test value. For the test value given, chi-square is 14.854. N equal 25, two-tailed. And from here, n equal 25, so degree of freedom is 25 minus 1 is 24. So using the chi-square table in the row with degree of freedom 24, find the chi-square two values such that the test value, chi-square, for the test value. The test value is this one. Chi-square equal 14.854 falls between what's two number. So you look at the chi-square table. Here is a degree of freedom is 24. So look at degree of freedom 24. 24. And the chi-square test value, chi-square is 14.854. Now 14.854 is on degree of freedom 24 is between 13.848 and 15.659. So it's between, figure out, is between 13.848 and 15.659. Here, degree of freedom is 24, and 14.848 is between the two number 13.848 is less than 14.854. This chi-square value is between the two number 15.659 between the two number. Now you look at the so that's is chi-square. Chi-square left equal, first one is 13.848. The area to the right of 13.848 is 0.95. This degree of freedom is 24. 13.848 chi-square is 13.848. Go top is 0.95. So this area is 0.95, which is when this area is 0.95 and degree of freedom is 24, then this chi-square left is 13.848. So using the chi-square table in the row with degree of freedom 24 and find the two values such that the test value chi-square is 14.854 falls between the two number, and the first number 13.848, the area to the right of 13.848 is 0.95, and use degree of freedom 24 and the 13.848 and go to the top. You got is 0.95. Is to the right of chi-square value 13.848 is 0.95, and that's to the right. So this value 19. So the area to the left would be 1 minus 0.95. This value is 0.05. So this to the left, this is 0.05. The p value is the two tails, is the p value. So looking for p values, so we need to figure out to the left tail. And the area to the right of second chi-square 15.659 is what? How to figure out? Degree of freedom is 24. 15.659. And you move to the top. 16.569. Move to the top is 0.90. So it's to the right is 0.90. So this area is 0.90. The chi-square degree of freedom 24. Chi-square left is 15.659. So to the right is 0.90. So the area to the left will be 1 minus 0.90. So this area is 0.10, this area. So therefore the area to the left, because this number is between the two, between 13 and 15, between the two number. So the area to the left of this number is also between 0.05 and 0.10. So the next, the area to the left of 14.854 would be between 0.05 and 0.10, between the two number. Between the number, because this number, this test value is between the two number. And to the left of this number is 0.05. To the left of 15.65 is 0.10. So to the left of the number between the two number is also between 0.05 and 0.10. And what is the p-value? The p-value is the sum of the area in the two tails. And each tail having the same area. So now we figure out the left tail. the left side is between 0.05 and 0.10, and the right tail also, because it's the same area. So right tail is also between 0.05 and 0.10. And the p-value is the two tail add together. And since the two tail has the same area, so the p-values is the sum of the area in two tails, Since the left tail is between 0.05 and 0.10. So double. 0.05 double is 0.10. 0.20 double times by 2 is 0.20. So the p-value is between 0.10 and 0.20. And because area in one tail is 0.05, between 0.05 and 0.10, and times by 2, 0.05 times by 2 is 0.10. 0.10 times by 2 is 0.20. That is the area in two tails, is we call p-value. So the p-value is between 10% and 20%. Then question 9. The medical researcher is interested in whether patients' left arms or right arms are longer. If 23 patients participate in this study, how many degrees of freedom should the researcher use when finding the critical value for a t-test? So n equal 23. Degree of freedom is n minus 1 is 23 minus 1 equal 22. So C's answer is the degree of freedom is 22. And question 10. What is a type 1 error? What is a type 2 error? Type 1 error is what occurs if one reject null hypothesis when it is true. If a null hypothesis is true, you should accept that null hypothesis. But one should accept, if a null hypothesis is true, then the correct way is accept the null hypothesis. But one reject the null hypothesis when it is true is an error. We call type 1 error. What is the type 2 error? Type 2 error occurs if one do not reject the null hypothesis when it is false. Because if a null hypothesis is false, we suppose should reject it. It's false, so reject it. But you do not reject it. That's what we call type 2 error. So null hypothesis is true. If reject is type 1 error. If a null hypothesis is false, you do not reject is type 2 error. Null hypothesis is true. Reject it is wrong. You should accept it. So we call type 1 error. If a null hypothesis is false, you should reject it, but do not reject is an error. That's called type 2 error.